Okay, the next recording here is about example 2.8. We are going to leverage what we learned from 2.7 and build onto this. We're going to try to do this in this same overall model where we have a buffer and a process and we have an overall. And what we've done here is they gave us these original numbers in example 2.7. We calculated the in-buffer inventory of blocks to be 70, which is 81 minus 11. We calculated the throughput of 5 blocks per hour across the board. And in this example, we're going to add 2 different types of products. So not only do we have multiple stages in Little's Law can work in a situation of multiple stages, buffer or process, for example, but we also have Little's Law for processes with multiple products. And so part of the question here is what is the number of in-buffer blocks, inventory blocks, for product number 2, which I believe is diesel blocks. Okay, so there's 2 kinds of blocks here, gasoline and diesel blocks. And we are going to augment this model to drill down into gasoline and diesel blocks. And here's how we're going to do this. We can go ahead and fill in this table by simply looking at what our flow time is here. We know that the flow time for the overall is, the relationship here is going to be 16.2 minus 2.2. So this is saying the flow time of that buffer, the amount of time that a block spends in the buffer, is 14 hours. And again, this is for the overall. So if I come over here and just type in overall for these rows, this gives us the overall picture. But what we want to do now is we want to dig into a whole nother level of product. And the way that I want to do this is I'm going to go ahead and copy these rows down here, and then we're going to add our gasoline product, as well as our diesel product. And what is the distribution for these 2 different products? I believe they said 80% of blocks machined are gasoline blocks and 20% are diesel blocks. So I'm going to go ahead and put in here 80% for gasoline here, and I'll just go ahead and do 1 minus the 80%. Whoops, let me get an equals for our 20% of diesel blocks. Okay, a little bit of formatting here. Let me go ahead and take this line out. And we're going to begin to fill in this portion of our model here. They give us some information, and there's a couple of questions. Let's see, at the very end the question is, can the manager compute the average flow time for each type of cinder block using this information? So what we're doing is we're looking at flow time for each type of block. So we want the flow time here, and we want the flow time here. That's where we're going. So how do we get there? First, let's put in some more information that they give us. The average time to machine a gasoline cinder block in the process flow time for gasoline blocks is 2 hours. So this is talking about process flow for the gasoline is 2 hours. So we can see here, let me go ahead and format this. Let me get a center alignment. 2 hours for the in-process time of the gasoline product. Okay. This number is 3 hours for diesel blocks. So we'll come down here and we'll put 3 hours for diesel blocks. The average in-buffer inventory of gasoline blocks is around 30. Where would we put this? The average in-buffer inventory for gasoline blocks. So this is inventory. In-buffer gasoline blocks is 30. Okay, with this information, how would we go about calculating the flow time for the gasoline and the diesel blocks? Well, let's see what data they've given us. So they've given us the 30 inventory for blocks. We have the 70 overall. So what we can do is we can take that 70 and we can subtract the 30. Let me try that again. And that gives us 40. So we have a total of 40 diesel blocks waiting to be processed in the machining department. Next, we're going to use throughput to find out what is the throughput for just the diesel. The way we're going to do this is we're going to take our 20% and we're going to multiply it by the overall 5 throughput, 5 blocks per hour throughput in the buffer and the process and the overall. That gives us a throughput on the diesel buffer of 1 block per hour. Since we know that this is the same throughput through the whole process, we have just identified the throughput for the entire diesel product line. 1 diesel block per hour. Now that we have our inventory and our throughput for diesel, we can calculate through Little's law. This is again using Little's law. We can identify that flow time for the diesel blocks, and the flow time for diesel is 40 blocks. Excuse me, 40 hours. 1 block per hour is 40 hours. Now there's 2 more steps. Now that we have the 40 and the 3, 40 hours in the buffer, 3 hours in the process for diesel, we can compute the overall flow time for diesel, which is 43. And these analytics are here. Here's some of those equations. You can follow the book. The last step here for this example is to identify what the flow time is for gasoline. And this comes from this equation here. And here is the ending equation, right? What we're saying is these flow times are weighted. So this overall weight of 16.2 actually comes from 80% of this flow time plus 20% of this flow time. And when we do the math here, I can do the math here in the equation. It would look something like this. What we're doing here is we're solving this equation. So 16.2 is equal to 0.8 of this T1, which we're solving for, plus 0.2, which is 20% of the 43 here. So we can do that by using this kind of formula. If we take the 16.2, we subtract the 43 times the 43 times, this is the 20% here, all divided by the 80%. That gives us a flow time of 9.5 hours for the gasoline block. Hopefully this model is helpful. It's a little bit different than the book's model. Let me know if this is helpful. Lastly, we can fill the rest of this in if we so choose. What we can do is we can take our throughput, multiply that by our weight of 80%. That gives us a 4. So now that we know that the throughput here is going to be the same for each one of these stages for the gasoline product. And then we can use Little's law to make the other calculations. For example, the 7.5 hours that a gasoline block spends in buffer. This is the flow time, 7.5 hour flow time in the buffer for one gasoline block. We can also calculate the inventory of the process by using Little's law. There's 8 blocks in the process. Overall for the gasoline, we can also use Little's law to do 9.4 times 5. That gives us 38, and that's also 30 plus 8, right? There's 2 ways to calculate that. Down here in the diesel, we can calculate the inventory by using Little's law. 3 times 1, that gives us 3, with the total inventory of that plus that, 43. And again, there's 2 ways to calculate this. You can sum these, or you can take the flow time times the throughput. And that fills out this entire table for multiple stages and multiple products.